Refilled water. Grab some dinner, which is just leftover dinner from yesterday. But all good. Some noodles. Some stoof. That is Twitchception. Get rid of that junk. Oh. Okay. Let us leave. Not really. Because altogether this will take 10 hours. And that's just roughly. It doesn't factor in me reading everything and reading it aloud. Which actually takes longer, among other things. Or me, eating my dinner while I'm reading. But some of these might be BS anyways. Like if it's just telling me general information that I already know. You'll learn what real-time means, and why it's important for the future of creative development. That is what the mission is. It's what is real-time. Okay. The ability to work in real-time environment is a major draw for Unity creators. Okay. The term real-time describes how quickly an image is rendered or displayed on the screen. The goal of real-time software is to render images so quickly that a person can freely interact with the project without any noticeable delay. When a project or application is real-time, the user never thinks about the fact that they're just watching a series of constantly updating images. Instead, they focus on the content. For tool sets like Unity, real-time interaction occurs for both the creators as they build their projects and for the end user as they use them. In the past, computers weren't powerful enough to quickly render visually complex scenes with physically accurate lighting and effects. In fact, a single still image might take several minutes, hours, or even days to render. To get the look they wanted, creators had to wait a long time to see what they had created. Any errors or adjustments added a lot of time to the production timeline. Iterations were very costly, and experimentation was almost unheard of. New ideas that might improve the final product were often ignored for the sake of meeting the deadline. This type of rendering, called offline rendering, was utilized for non-interactive media such as film, in which there is only one unchangeable set of images in the final product. Offline rendering can't be used for interactive media such as video games, where the user expects to control what they see and do. Real-time rendering technology grew out of video games to meet the demand for interactivity. Early real-time renderers were able to sacrifice visual quality, animation, complexity, and special effects. As computer processors have evolved, real-time rendering has increased in quality, yielding real-time, photorealistic images in today's games. It's gross. It's disgusting. Who wants photorealistic images in video games? Well, that's something else. Scarf down more food. I like how I have this in the little window, but right now it's like the main point here. Let me just... There, it is big now. When I actually get to using Unity, I'll just shrink it. If I even use it today. Either way, done eating food. 3. How are real-time tools used today? Today, Unity has gone beyond approximating the real world, and is now capable of rendering physically correct materials and lights in the editor. It can also accurately represent physics. These days, if a project deters from real-world visual accuracy and interactions, it is often decision rather than a limitation. The gap between offline quality and real-time rendering is rapidly diminishing. It's not one-to-one yet, but it will be, far sooner than most expect. A still from Hectic. A short film created in Unity using out-of-the-box features. You can watch the full short film here. I'm not going to watch it. Using a project specifically requires a quality level that can only be achieved with offline rendering. The benefits of switching to real-time are significant. Eliminating the need to wait for renders has changed the ways creators can work. In fact, creators who move their projects from offline rendering to real-time remove weeks or months from production cycle and give themselves more time to experiment with new ideas or polish what's already been designed. With real-time tools such as Unity, creators can spend all their production time on creating. So far, this only sounds useful for not me. I wonder how many people, like, use this terminology. Real-time 3D, blah, blah, blah. They really like to talk about the real-time stuff. Next steps. Real-time development is beneficial to both the creator and end user. With Unity, creators can create high realistic, physically accurate scenes for both passive and interactive media. In the next tutorial, you'll learn more about what Unity does and how it came to be. Do I care about that? Like, not to bash, but this is professional skills? I didn't know this was professional skills. I have professional skills. I'm like a god gamer. Sure. Good enough. Starting the next tutorial already. Wow. This one said it would take like an hour. No, I think that means for this whole branch. But, boy. Boy, oh boy. They didn't auto start. Continue to next item. I think I accidentally clicked out of it, that's why. I wonder if this one's gonna give me a quiz too. Excuse me. Overview. Unity began its life as a game engine but evolved to be a creative tool that's used by many different industries. That being said, Unity still retains its game engine roots, and the story of how and why it was created provides insight to why it works the way it does. If you're not sure what the term game engine means, you aren't alone. Game engines are constantly discussed in the game industry, but are rarely explained, which can be confusing for newcomers and creators in other industries. So let's begin by first defining what a game engine is. What is a game engine? This will be on the test later. Take notes. Wait, should I actually take notes about this? I don't know. The other thing said there was a quiz before. This doesn't say there's a quiz here. So I will believe it for now, until proven incorrect. The process of creating a game is a great deal more complicated than it appears on the surface. It seems very complicated, so that's worrying. The computer or mobile device on which you're reading this right now runs on an operating system that tells your device how to run. Power to the screen, keep the brightness setting to where you specified, initiate and maintain access to the internet, and display the text and images on the screen. It's also doing a lot of related work in the background, like regulating device access to its power source. That's a lot to manage, just to display some text. Yes, I know what an OS is. Thank you for telling me. Again. Like I'm back in computer class. Now, think about creating content rather than just reading or viewing it. If you've ever written an email, you know what you personally don't need to understand the inner workings of your email program in order to write a message. All of that other stuff is handled on your behalf, and you only need to focus on creating the content of your message. A game engine is exactly the same. I feel like it's not at all. A game engine is the point of convergence for all aspects of creating a game. Games, like all applications, are made of smaller pieces like 3D models, scripts, and audio files. When put together, they create the full user experience. If 3D models, scripts, and audio files were ingredients, Unity, and other game engines, would be the stock pot you drop them into. Exclamation point. A game engine is the point of convergence of all components that go into making a game. Thanks. Why don't they just have them all on this side, and then why do they have to be on both sides? That seems like a bad diagram. Like the operating system that's ensuring you're able to read this tutorial, game engines make sure that your game will display on the screen. Objects will be able to interact with other objects, sound will be audible, and application will be publishable in a format that your device can run. You provide the content, the game engine provides the tools to implement it in an environment that will just work. I feel like I should have gone through all of this stuff before I did the other stuff of using Unity. I feel like this stuff is for like beginner. Like this is like if you never touched a computer before in your life. Tutorial right now is what it sounds like. But maybe it'll change as we go along. But this sounds like stuff that I already learned back when I was in high school doing computer repair classes. Anyway, what do you do in a game engine? Now that you have a basic idea of what a game engine is, let's learn about what creators do with it. If a game engine is used to implement the content you bring into it, what is the content? In a game engine, the creator is putting together everything that the user will experience in the final product. If that product is a game, the creator designs gameplay such as jumping on platforms. If it is an animation, the creator devises the action being recorded. If it is a VR architectural visualization, the creator builds a photorealistic environment that the user will walk around through. The game engine also gives the creator a means to make their product into an interactive experience for the user. There's a great deal more that Unity is doing behind the scenes so that you, the creator, only need to focus on the all-important user experience. Okay, what don't you do in a game engine? Inside a game engine, you don't create assets, the objects and sounds that are the building blocks of the interactive experience. Instead, assets are created in a specialized external program called Digital Content Creation, DCC tools. Many DCCs are integrated with Unity to ease the process of importing them. The most common types of DCC tools used in real-time development include 3D programs like Maya, ZBrush, and Blender. I have Blender on my stuff. I have Photoshop, but I don't have any of that other stuff. I might have to get, I think GIMP is the free one. I don't know if Illustrator and Substance Painter are free or not, but might need to grab those or something. I do have Audacity also. Don't got that stuff. Programs for real-time development, rendering, and publishing 3D content. Examples, Unity and Unreal. I wonder how Unreal is. Like, would they have the same level of tutorial stuff for it, or is it more complex? I hear most people that get into this, that are, like, being self-taught, use Unity, but I hear a lot of schools can use Unreal at times, so I'm curious about that kind of thing. But I already know that stuff, so skip around. And upcoming tutorials will describe each of the DCCs in detail. Unity Asset Store, good news. Although learning to use the DCCs to create Unity assets can be an excellent skill to have, you don't have to build every asset in your projects from scratch. Hundreds of ready-to-use assets created with DCCs are available to you through the Unity Asset Store. Some of them are even free. You can download and import assets directly into your projects using a link between the Asset Store website and the package manager in the Unity editor via your Unity ID. In the upcoming tutorials, you go to the Asset Store to get specific assets to enhance your project, and you'll be ready to explore the Asset Store on your own. The Unity story. It started with a game. Goo Ball. The first product ever released by Unity Technologies was not a game engine, but a game. Doesn't look like a very good game. Anyway, in 2005, Unity's founders, blah blah blah, released a game, Goo Ball, for Mac OS. A year after its formation of their company, which is called OverEdge Entertainment, the game was created with an engine that they built from scratch with the intention of licensing the engine to other developers. How games were built before Unity. Do I care about this part? I don't really care about this part, to be honest. I don't care too much about this part. It's just like the history of it, and I don't really need to know the history of it. It's like interesting, but it's not needed for my education. App Store. Yeah, I don't need to know that. Not gonna lie, I don't need to know it. Unity's core value was once. Yeah. Game development today is simply and to move its focus away from games, but to open doors to much more. Okay, that's good. I understand. I get it. What can Unity do? Move on to the next one right away? So far, these are all pretty slow. So far, they're all pretty slow. In this tutorial, you'll learn about the different types of content you can be created in the Unity engine. By the end of the tutorial, you'll be able to describe how real-time creation software is used in different industries, identify a variety of real-time creators by their usage of Unity, explain what real-time game engine is and how to use it's used. I don't need to know any of that. Or rather, it sounds like they explained to me how it is in the first place. And if I can't explain it in like 5 words to a simple person, I don't know, I would need to talk about someone that already knows what it is. I don't know. A lot of this stuff seems senseless, if you like think about it in the long run. If I was an IT specialist, for example, and I wanted to fix someone's computer, if I tell them, oh, it's a problem with the OS, I just need to reinstall Windows to get it working. No big deal. They're gonna look at me like, what did you just say? Did you just call my ma a Luigi? I'll be like, what? No, I just have to reinstall the OS, okay? What the heck is OS? Are you trying to touch me inappropriately? Like, that's what happens. Like, people that you would talk to about this information won't know what you're saying anyway. So it's weird that you have to learn it so specifically, because when you brush it over in like a comment that's like a sentence long, you yourself, the person that's going to be using the info, already know what it is. But then if you talk, like if I was an IT specialist talking to another IT specialist, we're not going to care about the language at all. We're not gonna flip around the OS stuff or whatever. We're just gonna say like, yeah, Windows is doing the thing again. Oh, okay. Want the install disk? Yeah, thanks. Like, that's the end of the conversation there. We won't go into the nitty-gritty of it. It would just be dumb. So it always seems weird that people care about you learning the vocabulary when realistically no one uses the vocabulary. And if they do, that is very strange. Anyways, Unity is an interactive content creation platform. While it's best known as a tool for making games, it has been embraced by many different industries for its flexibility and ease of use. Unity is a real-time engine which allows for experiences that are fully interactive, not just for the end user, but for the creator as well. Unity allows creators to quickly iterate and collaborate on project with their colleagues, which speeds up the development and process, and helps teams arrive at a final finished product. Okay. What industries use Unity? Mario Kart Tour, made with Unity. I could make Mario Kart if I had like a group of like over 100 people making a game at the same time. Wow. Baymax Streams by Disney, made with Unity. This is just showing things that are made by Unity. I don't really care about the things that are made with Unity. I just want to be able to, you know, learn how to make a video game. So like I understand that stuff. Unity's used in a lot of things. I see the logo everywhere. Experience Unity in action. Best way to learn about something is to experience it yourself. We created an application that allows you to experiment with 5 different use cases in different industries. While these are small examples, they represent real applications in the fields today. While exploring the app, try to identify the differences, similarities in ways these industries use Unity. How does Unity help them? What does Unity seem particularly good at based on your experiences? I've already used enough things, like just by being a user on the computer. You use Unity all the time, pretty much. It's like becoming like a Java or something at this point. Yeah, it's everywhere. You use it on accident without even noticing. Unity is used in many industries in many different ways, but what they all have in common is the need to see, understand, or interact with physical objects in virtual space, making the unreal real. Don't use the Unreal Engine. To that end, creators create with Unity in just about every industry and job sector, and more are discovering the potential of real-time creation every day. In virtual space, anyone can make anything. All they need is Unity and an idea. In the next tutorial, you'll learn more about the people who create with Unity, how they do their jobs, and how they become real-time creators. Do I care? Like, I don't really care about the other people. I'm trying to do this for me. No offense, but I want to learn how to use it. In this tutorial, you'll get to know some of the creators who use Unity in their day-to-day work. Well, that's great and all, but like I don't want to know them. I'm not gonna meet them ever. View transcripts or videos, select show transcript while playing each video. Yeah, that's great. Creators coming. Blah blah blah. Who are real-time creators? That's a good question. Who are they? I won't know. Yeah, we got more experience. Dun 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 dun. Leveled up. I'm making so much progress. I'm great at this. Now this seems like good stuff. Create things, work with game objects in 3D scene. This sounds like what we're talking about. This sounds like the real big boy stuff. Okay. In this tutorial, I begin working in Unity Editor with more independence than you might have experienced with microgames. Using a new Unity project. In a 3D scene you create from scratch, you will work with game objects and explore the various ways you can manipulate them in the Unity Editor. In this tutorial, you'll create 3D game objects, blah 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 blah. Okay. Okay. Before you begin, get familiar with the editor controls. Try a micro game. They always recommend this stupid Lego game. I did that already. Create a new 3D project. Now this is the real stuff. This is the real video gamer hours. I just wish all the files didn't take up so much room. I do not need any of this stuff anymore, though, so I'm going to delete it. Even if it takes for a while. Just so I can save the space. Okay, well, those are all getting deleted. Yeah, it says that it'll remain on your disk, so I'm glad I'm deleting it like that. Okay. So we want to create a new project. I also want to check really quick. I have WebGL listed, so I don't know what problem I was getting before. But we'll start our new project. Open the Unity Hub, create a new project using 3D template. Name this project Essentials 3D Project. That's what I named it before last time. All templates. Oh, it looks like this has more stuff now. Interesting. I updated my Unity thing, so I'm seeing a few different things now. But, 3D template. Change the project name here to Essentials 3D Project. We'll just make the save location on the desktop so I can actually find it. We'll create it. You might see a prompt to download the 3D template if this is the first time you've used it. Look for this prompt on the 3D card when you select it. Create a cube primitive in your primary empty space. Right-click on empty section in the hierarchy. 3D object cube. Okay, I know how to create a cube, so I will just do that after I'm done with this. I straddle the line. Blah, blah, blah. Just, taking a hot minute. I'm waiting for it to create the project. This is like the bad part about trying to show this. Get the real time. Ugh. The real time waiting. Resolving packages. Resolving packages. Now. But Snake, you can't do that. How am I going to make you make a cube that moves in a circle? So it looks like they're going to make us turn into a floor into lava? I'm glad they're going to teach me about 2D stuff, it seems. Essentials of real-time 3D, essentials of real-time 2D. Because I think I'd probably use 2D, but I don't know if some things are 3D and they just look 2D, you know? So I'm curious to see what they define the differences as. Like, do I see everything in a 2D plane if I make it 2D? Or would, like, The Legend of Zelda top-down view type game, would that be considered a 3D game? Or would it be considered a 2D game? Or would it be considered a 3D game that has the camera pointed directly down, and it's just a JPEG that you're moving on the map or whatever? I feel like you could do that, but I don't know if that would count for anything. Anyways, I'm now going to shrink this down again. I'm gonna pop that up. Make it a little teeny bigger. A little teeny bigger. So then you can follow along at home. I don't think anyone would actually do that, but maybe you would. You're as dumb as me, trying to learn a program. Maybe you too. Or like, oh, I didn't see someone actually, like a real person actually do it. A real fake anime girl person that has a very deep masculine voice that definitely is not an anime girl. Explained it to me very well. I saw all their mistakes and I said, I'm not gonna do that. And it was successful. There you go. Okay, that's all fine. Okay, let's get back to reading. So they wanted me to create the object. Create a cube primitive in your empty space. Okay. Cube. In the microgames, you started in a scene that was already built for you, with characters that moved and responded to your commands, a rigid ground on which they traveled, and goals and obstacles to make the game interesting. Now, however, you are working in vast, boundless empty space. A plane that looks like the ground is just there, is just for reference. It is not even a rigid surface. The default 3D scene comes equipped with two important game objects, which are listed in the hierarchy window. Main camera, which controls what your players will see in the game view, play mode. Directional light, which simulates the sun and provides light that will reflect off your 3D, your game objects, to create realistic visual effects. So I wonder how many people change the game light right away, right? Because different lighting would have to happen, right? I wonder how that works. You will return to these after you have added some game objects to your scene, so that the main camera has something to view and directional light has something off which to reflect. Okay. Work with game objects in the inspector. In the inspector window, where you will view and change the properties of game objects and other types of objects. To explore the properties of your cube in the inspector, in the scene, view, select the cube object you have created. With the cube selected, look at the game object's property in the inspector window. Cube. Inspector window. They're both there. They're indeed there. Okay. Each section of the inspector represents a component, which is a set of properties and behaviors of the selected game object. Some components are built in to primitives, like ones you see here. Later you will add more components to give the game objects more sophisticated properties and behaviors. With the cube selected, the transform component displays the size, rotation, and position of the cube. Using XYZ values, by default these values are meters. Can I change it? No. I don't think I need to worry about that. Unity uses Y-up coordinate system, which means that in the editor screen space, the Y-directional is vertical, X and Y represent the horizontal plane, similar to north, south, east, and west. Some 3D applications, such as 3ds Max, use Z as vertical. Select F on the keyboard to focus on the cube. cube. Tip. The screen view window must be activated. You can select a game object in the scene view or right-click anywhere to activate the window. Okay, so that's why that didn't work last time. I didn't realize this is what they meant. So they wanted me to do this to orbit it. Okay. That makes more sense. By default, the move tool is selected and its gizmo is located in the center of the cube. The arrows point in the positive directions in each dimensions. The dimensions are color-coded. You can always get your bearings by looking at the scene gizmo in the upper right corner of the scene view. With the cube selected, change the Y value of the scale in the transformation component to 4. Okay. That is a rectangle, a pillar, a monolith, if you would. The cube height will change to 4. Zoom out as needed. What's the scale? I don't have anything that says height specifically, so they just are going off the y-axis still for that, but okay. We did that. You can use the hierarchy window to organize your game objects and define their relationships to each other. You can group them in a hierarchy to create more complex game objects. Oh great, they're going for sphere. We're gonna make a PP, because I don't think we need to. Right-click the cube in the hierarchy window so that it is selected, then select sphere. As shown, the sphere is the child game object of the cube. These two objects are now linked. You can operate them as a unit. So that's how that's gonna work, okay. Sphere. Okay. Okay. The sphere is inside of the cube, where you can't see it. Select the sphere in the hierarchy, and the gizmo will appear so that you can move it in the scene view to a location at least partially visible outside of the cube. It will be tall, not spherical, because its initial dimensions were based on the parent. Turn on do button. There we go. Okay. Makes enough sense. Select the parent cube and move it. Cube and sphere will move together. Try scaling and rotating your object too. Determine parent and child relationship. Drag the sphere hierarchy up the window to indicate the root level. Both game objects now appear as independent objects in the hierarchy. Okay. Now they're different. Was I supposed to do that? I don't know. It told me to. You've seen how to add simple game objects called primitives to your scene, and you've seen the ways these game objects are represented in the hierarchy and inspector windows. You've seen how to move, rotate, and scale game objects 2 ways, with numbers in the inspector or by physically changing them in the scene view. You're now ready to practically exercise building a structure using primitives. Okay. Save. Just to make sure to actually save it. Well, I guess I get it. Think I get it. I mean, I understood how to do that, at least. Create structure with primitives. There's this me making a blocky template. Okay, so, let's get into it. This tutorial is an exercise in which you will build an architectural game object made up of multiple primitives. That's complex. This exercise will give you a firm grasp on how to create and manipulate game objects, and it will give you practice navigating around a scene. Here's the structure you will build. I'm gonna build that. You're gonna build him? It would look cool if I could, like, put, like, a cool texture on it or something, maybe. As you build this structure, you might want to change your view of the scene to make sure the game objects are aligned. For review, see navigating the scene. I think I know how to navigate the scene, maybe. I don't know if they'll be aligned, but we'll figure that out. They don't really have, like, a ruler. So, that'll be interesting. Create an empty game object. It's a placeholder object that can be created in a hierarchy. It does not have a visible representation in the scene, and it can act as a container for other game objects, among other things, to be explained later. Hierarchy and select create empty object. Okay. Create empty. Rename this game object to monument. Okay. Select this new game object in the scene view. Reset the position. Reset the position by selecting the reset position button. Do it. Okay. 3 dots on the right. Just gonna make a note of that. I don't know if that's something I would randomly remember. But just in case. Okay, it did not tell me to delete the other things, but I think it didn't want me to have those. So I will get rid of my sphere and cube, and we'll just have our monument. Create the steps. In the hierarchy, right-click the monument game object and create 3D object cube. To create a new cube as child monument. Cube. Rename this new game object to floor. What if I don't want floor? Right-click on the floor game object and select duplicate. Duplicate floor 6 more times so that you have the original floor and 7 duplicates. Control D is the shortcut. Doing that one at a time would be annoying. Okay, we got that. Transform the steps. In these tasks, you'll change the transform component values of each of the floor objects to create the stair step effect. Select the first floor child object and change the transform component values in the inspector as shown below. Okay, 20, 0, 2, 20. Do these change automatically? No. That does look like a floor. It fits in the squares. It does fit in the squares. Wait, did I save that? Save it now. Do the same for the rest of the floor objects using the values indicated below. Okay, floor 1, 18, 02, 02, position 02. Okay. Being object 2. Oh, 4. 16. 16. Still 02. Then 14 and 06. Okay. Now we got our little guy. Little guy right here. Nice little teeny walkway. 3D steps. I made that. Oh, we're gonna crash. Why did I do that? Oh. I think that's changing the speed of the camera. No, actually, I'm not sure what that is. Well, either way, that's that. We made a few little steps. We got something going on here. There's something going on. Okay, so that's 1, 2, and 3. Okay, so now we have the rest of them still, though. Similar to this. That is definitely how it's looking. Values for floor 4. Okay, we still have to do the rest. They're all just passively going up to... So I'm just going to do all of those in a row. And then it is 12, 10, 8, 6. And save. Oh. No, you should have the steps of the monument. Why is it a different color? Why is it a different color? Mine's not that color. Like, do you see that? Like, I know the scene thing is a different color, but like mine is not gray. Like that. It is still this color. Box collider. Positions. Mesh filter. Yeah, shadows. Yawn. I don't know if it'll tell us how to color it or what later, but... Huh. Did I miss something? It says, by now you should have something similar to this, and that's what I had. You should now have the steps of the monument. Why is it gray, though? Or is this just because they're using a texture thing, and they're going to explain how to use the textures later, because it says get 3D assets. I don't know. Anyway, create another cube within the cube primitive as a child. Yeah, rename it wall. Wall. Change the inspector values as shown. B5. Human 10. Well, it's kind of neat that you can see the shadow being casted by our solar point here, our sun. You can see the shadow being casted in real time. Kind of neat. Duplicate the wall 3 times and change the transformation components as shown below. Okay, so we just control D. And we want all the same values, but what are we changing? Okay, we're just changing the positives and negs. So first one is positive, positive. Okay. Second one is positive, negative. I wonder how many people use the natural lighting in Unity. Or if they get something to edit it somehow. Or if you even edit the lighting itself, or if you just edit how the shadows react. Anyways, then it's negative, positive, negative. Positive. Negative. Okay. We got the walls to our monument now. You will now have 4 walls at 45 degrees. That's true. Create the roof. Create a new empty game object as a child of the monument and name it platform. Drag all the floors into the platform game object. This creates a nested game object in which objects are nested at multiple levels as the children of one game object. In this case, the monument game object is the parent and all the floor objects are its children. When you group objects together like this, you can manipulate them to get all together and make copies of the whole group while still maintaining the relationship between them. We're not gonna break up, Dad. We're not gonna do it. Okay. So those are all together. All the floor objects are together. All the wall objects are by themselves. Duplicate the platform game object. The duplicated platform will include duplicate child objects. Rename the platform to roof. Oh, I see what you're doing. Roof. Okay. Duplicate platform will include duplicate child. First, rename this copy platform to roof. Select roof and use the move and rotate tools to put the roof onto the structure. Try positioning the roof in the scene view without changing the numbers in the transformation component. But when you're done, the numbers should look like the ones shown above. Honestly, it kind of looks better like that, not gonna lie. They have it going flat. I don't see why you would try to do this like this. Huh, interesting. It's clipping a little bit though. Okay, now it's not clipping. I mean, I tried to rotate it myself. You all saw me. Tried to rotate it myself. I guess that's still fine. It kind of looks cooler with the roof with that though. but interesting. We have our little weird shrine now. Got some shadow effects going on. Okay, I can dig that. Yeah, like, you can position it, but it just seems like it's a lot easier to fine-tune. Like, even if I was positioning it like that, I would probably still click on the numbers and then use the arrow keys to... Actually, they don't let you do that. Really? Huh, that's weird. I wonder if they have anything else for that then. They have to have stuff that lets you do, like, little increases, right? Instead of just guesswork. Maybe not. Probably, like, some plugin or something. Either way, we did that. Next up, so you've created a monument in Unity. Along the way, you learn some new concepts and practice some old ones, such as creating a game object as container for other game objects, duplicating game objects using transform component to manipulate child objects, nesting game objects to multiple levels, using the move and rotate tools to transform a child object. Next, you'll glimpse of the power you have over game objects by doing more with components. Okay. Arts and animation level. Sure. This one says 25 minutes. I mean, I'm definitely learning how to use the Unity editor itself, which is good. So let's see what we got going on now. Components add behaviors and functionality to a game object. You have used the transform component, and that is just the beginning. In this tutorial, you will add another component, the rigid body component, which gives the game object physical properties so that it can interact with gravity and other game objects. You will also position the main camera to watch how a game object responds to gravity in 3D. Is this the ball? Is this the ball? Am I gonna do the ball? It sounds like I'm gonna do the ball. Oh boy, I'm gonna do the ball. Create a new sphere game object in the hierarchy. I like how here they don't show that they're using this still, but they are. Or was it there and I'm just blind? No, they don't have it there. Sphere. Create a sphere in the game hierarchy. Move the sphere to the space inside the monument so that it is positioned in mid-air scene above the steps. Okay. Oh yeah, I'm still on the rotate tool. I want it to be in like the shadow area, just so I can actually see the shadow interact. I think that would be neat. Like right there. It has it like down 3 steps or so. Yeah, back a little bit more. Right there. Okay. I don't know if that's too high up, but... Okay, well I moved it over. Position the main camera. In every new scene, there's a camera like the one shown below. This camera, named main camera in the hierarchy, captures and displays your scene to the player as it appears in the game view. While the scene view is where you build your scenes, the game view is the preview of the way your game appears to the player. The camera in your scene is a game object like any other. When you select it, you will see its transform component in the inspector window. You can change these settings as you would with any other game object. Note that scaling a camera will have no effect. When you select a camera, you see the outlines of a pyramid-like shape called the frustrum. The frustrum shows you what part of your scene the camera is viewing. Anything outside of the frustrum is not visible to the camera. When a camera is selected, you can expand the camera component in the inspector to open a camera preview window that shows you what is visible in the camera scene. Move the camera to a position where it can see the ball and the steps below it. You can also move the camera to align with your current scene view by selecting it in the hierarchy window and pressing Ctrl-Shift-F. Main camera. Ctrl-Shift-F. Shift off. I feel like this is a pretty decent view, or if you want to see a ball drop. This is pretty interesting. I actually should write that one down. Camera. Okay. That is a good one to take note of. Select the play button to run the game. Notice nothing is happening at the moment. This is because you still need to apply a component to the sphere to tell it how it needs to interact with physics of the game. In this case, you need to make it solid so that it reacts to gravity. Okay, well let's... Okay, this is the game right now. Interesting. Make the sphere solid. Remember when you created a sphere that was inside a cube? Objects in the physical world don't exist inside other objects that way. But in a Unity scene... Wait, why not? By default, game objects don't have mass or respond to gravity. To make a game object behave like a real-world physical object, you can give it physical properties by adding a rigid body component. To add a rigid body component to a sphere game object in the hierarchy window, select the sphere, select Add Component button in the inspector window. Okay, sphere, component, add component. I'm guessing I'm going to go to the rigid body component, right? Add components. Use the search bar to find rigid body component. Oh. Rigid body. Okay, so stuff like that I'll just need to remember, it sounds like. That sounds like some annoying stuff. Components. Like, that stuff would actually be annoying for me too. Just like, oh yeah, of course I remember the rigid body component. Everyone does. I mean, I guess if you use it all the time, you probably would remember it, right? So maybe it's not as big of a deal as I make it out to be. I guess this terminology is the stuff that you'd want to actually know. Like this is the terminology I want to learn about. I don't care about about the history of Unity. Like it's interesting enough. Maybe I'll watch a documentary on it or something. Make me cry at someone's sob story or something, but I don't care about it in text. It's not gonna help me learn how to use the system. You making Unity out of a toaster or something isn't going to help me learn how to use it. No offense to the people, but I want to learn how to use it, you know? Anyways, we selected the rigid body and not the 2D one like it says. Make sure you select rigid body component. In the rigid body component in the inspector, select use gravity if it is not selected already. Use gravity, it is selected, it has a check mark on it. Okay. So it is selected. To see the effect of these properties, start the game by pressing the play button, which will display the game view. The ball falls and rolls down the steps. If it does not roll, try moving it to a new position using the transformation tools and run the game again. Okay. I did it. I'm an epic gamer. I did it. I just have to do it again. Just look. I did that. I did that right now. That was all me. You don't get that anywhere else. Like that was me 100%. Hang on, I have to go tell everyone about this, that I made it. A game. It's a game about a ball that rolls as soon as you start the game. It's a very riveting game. Well, anyways. Back to the important stuff. Note for physics best practices, see this tutorial for more information. Should I do that now? I don't like how they do crap like that in this tutorial stuff. They're just like, note, go do this tutorial if you want to learn more about all of this other stuff. And it's like, couldn't you just like put that like after, like later? Why do I have to do it now? I won't worry about it right now. I'll click on it. What does it say? It only says that it has 1 steps. So maybe it's fine. Physics best practices. In this lesson we will be looking at some of the best practices for when using physics in the game, and some evidence to demonstrate why they should be used. Layers and collision matrix. All game objects, if not configured, are created by default on the default layer, where by default everything collides with everything. This is quite inefficient, establishing what should collide with what. For what you should define different layers for each type of object. For each new layer, a new row and column is added on the collision matrix. This matrix is responsible for defining interactions between layers. By default, when adding a new layer, the collision matrix is set for that new layer to collide with every other existing one. So it's the developer's responsibility to access it and set up its interactions. By correcting setting layers and setting up your collision matrix, you will avoid unnecessary collisions and testing on collision listeners. For demonstration purposes, I've created a simple demo where I initiate 2,000 objects, 1,000 red, 1,000 green, inside a box where box container. Green objects should only interact with themselves and the container walls. The same red objects. I don't know the test. All the instances belong to a different default layer. Okay, and there's string of testing is needed in case. Okay. This is interesting. The image below is taken from the demo itself. It has a simple manager which counts the amount of collisions, automatically pauses after 5 seconds. It's quite impressive the amount of unnecessary extra collisions occurring when using a common layer. Default collision layer. I mean different collision layer, common collision layer. Interesting. Collisions amount to over 5 seconds. For more specific data, I also captured profiler data on Physics Engine. Separate layers. Common versus separate layers, physics profiler data. There's a difference on the amount of CPU spent on physics, as we can see, using a single layer to separate separate layers. Raycasting is a very useful and powerful tool on the physics engine. It allows us to fire a ray on certain direction at certain length, and it will let us know if it is hitting something. This, however, is an expensive operation. Its performance is highly influenced by the ray's length and type of colliders on scene. Here are a couple of hints that can help on its usage. This one is obvious, but use the least amount of rays that gets the job done. Don't extend the ray's length more than you need to. The greater the ray, the more objects need to be tested against it. Don't use raycasting inside a fixed update function. Sometimes even an update may be an overkill. Beware the type of colliders you're using. Raycasting against a mesh collider is really expensive. By expensive, do they just mean that it uses a lot of CPU usage, or what? A good solution is creating children with primitive colliders and try to approximate the mesh's shape. All the children colliders under a parent rigid body behave as a compound collider. If dire need of using mesh colliders, then at least make them convex. Be specific on what the ray should hit, and always try to specify a layer mask on the ray cast function. So pretty much, if you got everything that is just if everything is in the directory, the root directory, then it's going to mess everything up. You're going to explode your PC. If you put everything into folders and make them parents, and if you make them the sub-parent things or whatever, then you're going to have a lot less issues. That is what this is telling me so far. To my understanding. Be specific, there is trait. Explain the documentation, but what you specify on the raycast function is not the layer ID, but a bit mask. So if you want a ray to hit an object, which is on a layer, which is ID 10, what you should specifically specify is 1 greater than 10. But shifting 1 to the left 10 and not 10. What? If you want for the ray to hit everything except what is on the layer 10, then simply use the bitwise complement operator tilde, which reverses each bit on the bit mask. We developed a simple demo where an object shoots a ray, which collide only with green boxes. So is this like explaining how like hair physics would work? All of the red parts would be like the person's face, but then the green parts is where the hair could actually touch? Because the hair wouldn't go into the person's face. But if they're colliding with it, then wouldn't the green parts not be the hair? The green part would be like something else. I don't know. Because wouldn't it want to collide against it? Or does colliding mean something else in this? Impact on performance. I might have to study up on this later. It sounds a bit more complicated than I'd think. Just reading over this in 5 seconds. It's best for your project if you're developing a 2D game or a 2.5D, 3D game on a 2D plane. Using 3D physics engine is an overkill. The extra dimension has unnecessary CPU costs for your project. You can check the performance differences between both engines on a previous article I wrote specifically on that subject. I mean, it makes sense that 2D physics would not be as CP heavy. Body components an essential component when adding physical interactions between objects, even when working with gliders as triggers. We can. So, like, is moving this ball wasting my CPU away? Destroying it? Or is it simple? Because I didn't, like, add any, like, optimization to it. Like, this is what would cause optimization problems, right? Maybe that's how optimization stuff has problems with. If someone has, like, if someone had, like, a game like 7 Days to Die, and it was made in Unity, for an example, and, in 7 Days to Die, you have, you know, all your items, all your zombies, all your weapons, but, everything is running outside of, everything is running on the root directory, let's say, and then, when you do anything, all of the colliders are interacting at the same time, because they're all on the root directory. Everything is colliding with each other at once. When you're interacting with anything in the world, then everything is being used at the same time, we would say, instead of going in like a process. Maybe that's my way to try and figure it out in my head. That makes any sense. Anyway. Feel like I understand this somewhat. It was fine. Okay, anyway. Experiment with falling game objects. Try variations of this exercise. Move the sphere game object and the main camera to get the results you want. More things to try. Add more spheres with rigid body components at varying heights. Add other primitives and see how they behave. Drop objects in different places. Rotate the monument game object. One thing to note is that you can change the properties, values, and position of a selected object while the game is running. But when the game is stopped, all values will revert back to what they were before the game was started. This is used to test different parameters during runtime. But if you want the changes to be permanent, you need to make the changes while the game is stopped. Okay. You've seen how to add properties to game objects through components and use the rigid body to make game object respond to gravity. You also saw how the game view differs from a scene in view, and you manipulated the main camera to change the game's view's display. Next, you'll add more components and make 3D objects look more realistic in 3D space. Okay. That sounds reasonable. That sounds reasonable. I can get behind that. I can do that, Luigi. Thanks, Mario. I appreciate it. Good guy, Luigi. Good guy. Thanks, Mario. You're just waiting for your stuff to load, though. Yeah. Materials are components that define the surface characteristics of objects and how those surfaces interact with light. In each new 3D scene, directional light is included to simulate the sun. In this tutorial, you'll create a simple material to change the visual appearance of a game object and use a material to change the physical properties as well. The directional light will bounce off the game objects with material to create a visual realistic effect. Okay. I believe you. I can understand that. I think I will break really quick just to go to the bathroom really quick, so I'll be right back. Okay. I grabbed a slice of pizza. Oh! Before you begin, the visual appearance of the material will come from an image file. You can download the file used in steps below. Where? By selecting tutorial materials in the masthead at the top of this tutorial. Oh. I'm just save it to desktop for now. Okay. We did that. To make your Unity windows match the examples below, right-click the tab of the project window and select two-column layout. And match the examples below. Isn't it already matching? Kinda looks like it's already matching. Yeah, it's already matching. Right-click the asset folder in the project window and select Create Material. Rename the new material Brick Material. Okay. The preview of the new material is a 3D sphere. So that you can see how light interacts with the material at many angles. When you select the material in the project window, a more accurate preview appears and a resizable pan of the inspector. To import the file into the project, you can simply move the download file in the asset folder for this Unity project, which is represented in the project window. Ah, that's how I do it. Okay. I did it. Oh, there it is. Okay. I definitely see it now. Create the brick material. It is a brick material. Select the brick material in the inspector window. Select the circle icon next to the albedo property. Albedo and compass that reflect the properties of the material based on the solid color of an image. You want me to select it? Select the circle next to the... Create a new game cube in the scene. Onto the cube in the scene view. Okay. So... Just move over here right now. Cube. I don't know, make it a big cube. Drag the material into it. Okay. Cube now displays the brick material. To change the scale of the material, select the cube, open the brick material component in the inspector, and change tiling X and Y properties. Smaller numbers make bricks appear larger. Okay, do I want to change this? I guess they're just telling me, like, test it. So, I don't know. What if I made it 10? Not gonna lie, I'm not noticing anything different. Select the cube, open the brick material component in the inspector. Smaller numbers make the bricks appear better. So wouldn't bigger numbers make it appear smaller? Oh, that's what I'm doing wrong. I'm using the wrong one. Okay. What if I did? Oh. Okay, now I understand. I was looking at the wrong one like a dummy. I was looking at the secondary maps when I was supposed to be looking at the main maps. Okay. Materials. I'm just gonna make a quick little note of that. Make sure I remember that. Adding a physic material. Earlier you added a rigid body component to a game object to give it physical properties. You can also add additional physical characteristics with another type of material called physic materials. With physic materials, you can make an object bounce and change its friction and drag properties. These properties take effect when the object is under the effects of gravity. Physic materials don't change the visual properties of the game object mesh. In the project window, create a new folder called Materials. Right-click the Materials, Asset window, Physical Materials. Rename Material Bouncy Ball. Okay. Folder. Materials. M key still doesn't work. Right-click the Materials folder in the Asset window and select Create Physics Material. Bouncy Ball. Select the new physics material. Change the bounciness value to 1 in the inspector window. 1. Are we going to make bricks bounce? Is that what we're doing? Select the cube in the inspector window. Select Add Component and add rigid component. Okay. Cube. Wait, they want me to look at the cube. I'm being a dummy. Cube. Add component. Rigid body. Wait, did they want me to add the rigid body component? Yeah, they did. Okay, good. Your cube should already have a box collider component added to it. This component is automatically added when you create the cube in the scene. Drag the new bounce physics material you created earlier into the materials slot in the box collider component. Okay. I don't know why I had to drag it, but... Drag the new bounce physics material you created earlier into the material slot and box collider component. Run the game. Your cube should now fall to the platform and have a bit of a bounce when it hits the floor. Experiment with your bouncy cube. Try rotating it, duplicating it, making cubes fall on top of each other. What if I don't want? What if I don't want to leech? It's so hard to know what planes you're working on. Okay, so it's giant. Yeah, I should make it like that. I'll hit play. It's so cool. I can do the video game things. Can you do the video game things? No, you can't. Well, I made a ball roll. And I made a box. A box of bricks bounce. Look at that box of bricks. It's bouncing. Also, wait, hang on a second. Is this still... No, those textures are fine. Okay. Alright. Well, I mean, that's pretty cool. Adjusting the lighting in the scene. Oh yeah, I haven't saved in a hot second, so... Double save. Oh, I didn't notice. When did that freeze? I keep switching in and out of different stuff. I didn't notice. Anyway. In a new 3D scene, an object named Directional Light... Oh wait, no, they're just saying in general? Okay. Is included to simulate sunlight. You can manipulate this light with transformation tools like any other game object. Light directionally light in hierarchy window. Okay. Directional light. Change the rotation of the light by using the transformation tools move, shortcut key, W, and rotate with E. Directional light. Simulate light source that bathes the entire scene in light coming from a specific direction. Changing the position of the light will not have an influence on the scene, but changing the rotation will change the angle of light in the scene. Take note how the sky ambient light changes as you change the angle of the light. Okay. Well, that looks kind of cool. Yeah, that's actually pretty cool. I didn't really pay attention to before, but how did the shadows look one year? Oh yeah, you can't see them move. I wasn't really paying attention to the shadows because I was just happy that things were moving that I put there. So that was neat. Okay. Directional light is just one type of light. If you are interested in other types, see types of light. Is this like a giant... Okay. This just actually explains lighting completely. Explains spotlights, directional lights for that, area lights. So I'm guessing area lights would be what you'd use for, like, lamps. Directional light would be suns. Oh wait, maybe point light would be it. Either way, different types of lighting. I understand. Okay. In this tutorial, you've seen how the materials and light work together to make a game object look visually realistic. You also used material to add physical properties to a game object, and you adjusted directional light. In real-world applications, however, you'll need more than spheres and cubes. Why can't I use spheres and cubes? My whole entire RPG will be spheres and cubes. It will be my magnum opus of just spheres and cubes, and you'll cry. That sphere that is slightly blue is upset about the pink sphere being sad, and it'll be a great experience. Happy face. Clear instructions. I'm not super happy. I'm never super happy. Okay, now we gotta steal art on the Unity store. Not stealing, I know, but it's funny. It's funny to me. Anyway. The Unity engine is where assets come together to make interactive experiences. But it is not necessarily where those assets are made. This tutorial explains how 3D assets are built using 3D digital content creation tools, 3D DCCs, and how you can get assets built with these tools from the Unity Asset Store. We'll show you how to import some assets that will be useful in the challenge for this learning project. Like, stuff like this, just learning this stuff in general, so far, it just feels like, you know, it's like a puzzle, in a way. Like a puzzle. But, you're getting all the pieces together and slapping them on, and it feels good when you get, like, that one corner piece, and you're just like, oh, I got the corner piece, now I know where this piece goes. And you get, like, 3 more pieces in. And then maybe you don't know how to get all the stuff in the middle, but you start seeing the puzzle come together, you know? It makes you feel good. So that's cool. Okay, so that's just telling you about how you can create 3D characters and art stuff. And these programs are to model the shape of a 3D object, rig it so that it can be animated, animate it so that it can move in particular ways, and texture it to give it color and shading. An example of this is shown below. So what program is this? Is this Blender? Is this Maya? What is it? So, the bone structure is how you rig it, right? Sometimes I thought people add, like, the things in, like, essentially what I was doing with cubism and stuff for making a VTuber model is what all this stuff is for. So I guess if I wanted to make a 3D avatar for that kind of stuff, I could use this too, essentially. But I don't know how to draw and stuff, so I can't use it. The 3D assets made in DCCs are brought to life into real-time engines such as Unity, where they're integrated into a larger project like a game, simulation, or animated film. Okay, I understand. Other resources for 3D assets in Unity. It is possible to create 3D art and environments within Unity Editor using a tool called ProBuilder. ProBuilder has limited functionality compared to dedicated DCCs, but it is helpful for artists who want to quickly model 3D objects without opening an external editing tool. Okay. Not everyone has time to learn 3D DCCs, or the budget to hire someone to create 3D art for them, but there are many online resources for obtaining high-quality assets, in addition to sites like CG Trader and TurboSquid, which offer 3D models for all purposes. The Unity Asset Store is an invaluable resource for art specifically designed with Unity in mind. Watch below to hear more about resources for getting art in projects.
Let's say you don't know how to do 3D modeling, but you still want to make a game. You still want it to be 3D. That's something you can still do, because Unity's Asset Store will provide you with the art assets you need in order to make the game you want to make.
Even though I can model and I can draw art, making a game takes a lot of time. And so I use the Asset Store a lot to finish the first tree in my first game, Home is Where One Starts. The license of the Asset Store allows you also to modify those things and still use them commercially. And so it can be an invaluable resource for people who want to finish their game, tell their story, and get it done in a reasonable time.
You can also directly model in Unity. We have this add-on called ProBuilder, and what that allows you to do is the same kind of modeling that you'd expect in Blender or Maya or 3D Studio Max, and so you can basically create levels directly inside your Unity scenes.
That wasn't very informative. Was not. I was just kind of telling you what they already said in the writing. Exercise. Creating a 3D art is laborious, time-intensive practice that requires patience and dedication. To gain an understanding of this process, search online for a video of speed art using DCC tool of your choice. Speed art is a genre of online video content, recording someone's artistic process sped up so you can appreciate all the work that went into it. Watch one of these videos and consider, was anything about the process surprising? Share your observations in the comments. What comments? Get assets from the asset store. Ah, yes. The way that I can make a video game without having to be an artist. I can be just like all of those people that make survival crafting games that are in the that are in Unity, that just only use Unity things. Go to the Unity Asset Store. This link will open in your default browser and log in with your Unity ID. Okay? And anything you acquire through the Asset Store will be linked to your Unity account and will be available in the editor as long as you are signed in with the same Unity ID. In the Asset Store, search tab, type Materials to search for material assets. Materials. Okay. In the pricing section for the filter panel, select free assets. Select a free asset package containing materials. We recommend Yug use free ground materials. Okay. For the complete up-to-date instructions on downloading and importing your assets, I prefer to importing assets from the Unity Asset Store. I'm pretty sure I know how to do that. I just have to go to the package manager, right? And, do I need the Asset Store part? I don't think I do. Then go to My Assets. And then I would click this and download it to this one. Import it. And that should give me all of the stuff in my project. Import. Okay. Select one of the materials and drag it to the ground, onto the ground platform. The material is now added to your game object. Okay, well, there's definitely a lava texture, I guess. This looks like a interesting PNG. PNGs. Okay. And this turtle unit throw it. Okay. Yeah, I did that stuff, I guess. Clear instructions. The floor is lava. Okay. In this challenge, you will build your own scene using primitive game objects and free assets. In this process of meeting this challenge, you will create a new 3D scene, create new primitives, navigate 3D space in the scene view, move, rotate, and scale game objects, move, rotate the main camera, add a rigid body component, To game object, create and apply new materials. Playtest your game. In-game view. Okay. Start a new Unity project using the 3D template. Oh, they just want you to do a whole new thing. Okay. New project. 3D. Should I name it anything? Unity-kun? I'll just name it The Floor is Lava. How about that? Select, create project. Okay, well, while that's doing that, I'll keep reading on. If you want to use an import asset, import them. Using Unity primitives and any imported assets, create a path for a ball to roll from one location to another without falling or touching the floor. Start by creating a floor object and then using other assets and primitives to lay out your scene. Import materials from Unity, asset store, or create your own to give your scene some life. Using the same steps covered previously under Make the Sphere Solid, add rigid body components to relative elements in your scene until the ball can roll down your track. Position the main camera to find a good viewpoint. Run the scene to test it and make adjustments as necessary until the ball runs through the whole track you created. Apply any other skills you've learned to make your scene uniquely your own. Be sure to save your entire project by selecting File, Save Project, or by selecting Save when you exit the Unity editor. Okay, interesting. So pretty much this is like a test. This is like your first test on Unity. But I'll just save this, I guess. Why don't I just use this? I guess it doesn't matter too much. This was something telling me what to do for everything. Let me re-maximize this. Okay. I mean, let's go to the asset store. This isn't what I wanted to go to. There we go. Already looked at that. K materials. Stylized lava materials. What would be like a good ball? This UQs has a lot of stuff. I mean, I guess this seems like the closest to balls, right? I'll grab it. Really that easy. So we want to make essentially a small little video is what we're really doing. But we want package manager. Gonna go over to our assets. Want to import these into our game. So Do I have to re-import it every time? No, if I downloaded it, then I can just do it in general. Okay. What is this stuff for? I don't know, I'll just get it anyway. Is this just like an actual... Is this like just a body that you can mess around with? Is this like all you actually get? Character is really inspiring. I came up with the idea. The viewers might like cartoon aliens. Send a little liquid cyborg. .3D prototyping pack. I guess since we're just making random stuff, I'll import a few of these and see what we can do with it. Obviously, I won't import the danger zone for the Lego, but we'll import a few of these materials and stuff and see if we can make our ball not touch the lava. And we'll actually make lava, because why not? Okay, I guess it'll take a little bit for all this stuff to load in. I forget that it doesn't show all of the things I'm doing to make this stuff load in. It doesn't show that. That's kind of funny. It just randomly pops up after I'm done doing all that. Oh, the prototyping pack is like an actual complete thing, I guess. And not just materials. Okay, well, we'll just get those materials for now. And, let us see. Create a path for a ball to roll from one location to another without falling or touching the floor. That is our objective. Okay, so let us leaf. This will be our ball. This is American Idol. This is a ball. So our ball is going to need a rigid body, so it moves. It'll use gravity. How the heck does this one look? Yeah, we'll use this. What should I use this? Thing's all weird. What about this one? Can I just throw these over each other? That's sort of weird. Let's go futuristic. Or maybe really old magical artifacts. So that will be our ball. Oh. Make it bounce a little bit. I changed themes. Will that change this too? Okay, yeah, it does. Let's keep things nice and neat also on here. Okay, there we go. That's what we like to see. Okay, now the ball can bounce. Ball can bounce, but we have no floor. Got nothing else in this wide open space. We need to correct that disgusting outrage. Main character, Coon. And we will create a plane. We'll center the plane. Okay. So what if I just made this like a very big old plane? Okay. It's a little bland. It's a little too big. Well, maybe that's the point. I should make it smaller or something. What does this do? Let's take our main character Coon over here. I should make main character Coon bigger. Let me see where the light is. Well, I guess technically the light's fine then. What I want to do is Control Shift F. Change it to this. Okay. And then we want to start making our path. Path of the hero. Don't know how many I'll need, but okay. So what I wanted to do was there we go. That's what I wanted. Oh. Oh. Hmm. Let's see. bounciness, friction. Hmm. Interesting to work in 3D planes, to say the least. I'm just curious to see how this will work. I don't know why it's going so slow. This is because of the textures. Very cute. Oops. No drag coefficient means no dampening. The mass of the body. Speed. Huh. I wonder if when this is rendered, if it'll run better. And position scaling. Hmm. Hmm. Where's my cube going? I mean, sphere. Okay. Yeah, if I put it at 90 degrees, that works. Then I just have to figure out where to actually put it. Eh. Hmm. Okay. I just want to. Maybe like 25. It moves very slowly. Ugh. Oh, that's interesting. It collides with the circle's top half. I have to use something else. What the heck is a quad? That's weird. Uh, I'll clear another plane. Ooh, yeah, that's pretty good. That is way too long. Why did it turn black? Is it because of the shadows? Anyways, let's do 8. 9? Wait, not 89. 6. Six point 5, 6.4, 2. That looks terrible. That actually looks rather normal. So, what happens if I change the maps? Would it move faster? So I put the maps to 2. It's almost perfect. Okay. Would this change the velocity on it? Angular drag, mass. I'll just turn this to 10 really quick and see what happens. I don't feel like anything really changed that much. It seems like it's moving faster, though. It's losing velocity. Still losing velocity. Still losing velocity. Oh, it would have been so cool if it rolled back. So what happens if I make it 20? For mass. Seems like it falls faster. Maybe? I don't know what changing the mass does exactly. Okay, we got the path. Got that. We got main character code. Let me just see. Unity, change velocity. Increase speed of ball periodically. A lot of this is just seeming like it's just use coding and not the simple answer of do this or that. I'm gonna set this back to 1 and see what the differences are. If there is any. It looks like it's moving at the same speed, so I don't think changing the mass did a lot. I think we'll have to figure out the coding stuff on that or some other component or what have you. Because it looks like the velocity is relatively the same. Only it stopped right there. Would be perfect. Oh. Okay, well, for all purposes, it seems like we did that one. So we did that. Did you make the ball bounce? Did you make the floor lava? Or did you go in a different direction? Whatever you created, we'd like for you to share it with the Unity Learn community, but first you'll have to build your project to be playable. That's the next tutorial. Does that mean I'm going to, like, actually make... like, do actions? Or is this going to be something else? When your game is ready, it is time to create a build, which is a standalone playable version of your game. Unity supports the most popular platforms, including mobile, Android, iOS, which also allows you to quickly publish your project with a few simple clicks. Keep in mind that while it is easy to publish to different platforms, it is up to you, the game developer, to make sure that your game can run on the target platforms. For example, the resources available on a smartphone are vastly different from those on PlayStation. Just because you can build for a platform, your game will not necessarily run on that platform. In this tutorial, you'll create and publish a WebGL build so that you can share your project on the web with the Unity Essential community and your fellow creators. If you like, you can publish your WebGL build on Unity Play or use other hosting platforms. Okay. Follow these setups. Okay, well, I will do that, but I have to go to the bathroom really quick, so I'll be right back. Okay, back. Bookbuck. You're going to create a build that others can play online on WebGL builds. The best fit for that, the process broadly is the same, publishing for any other platform such as Windows, Linux, or Mac OS. To make your submission, follow these steps. To create and publish a WebGL build of your Unity project. Once you've done that, then use the form below to submit your project to Unity Learn. The submission is required to complete this mission of the Unity project. This is what I've already done before, right? Check the real package. Does this not have the actual thing here? Oh no, it's there now. Good. I know all that stuff already. We did it in the Lego thing. I'm all good with that too. Okay. That one I'm fine with. We're all good with that. Don't need that one. Okay, so... we need to publish the thing first, so that is what we're going to do now. Okay, so... publish WebGL project. Get started. Build it and publish. Switch to it. Oh, that's fine. So now this will compile the game, do its little magic. Our game that is not actually a game, is just watching a ball roll slowly. Maybe faster on the game thing when it is not doing everything with Unity. I kind of like the interface. I feel like the interface is simpler than I thought it'd be. Feels like I can grasp the interface at least. Though I don't have anything for coding and stuff, and I know you can do that in here. I know you can like click on certain objects and whatever, throw up the string of code for it. And I gotta wonder, for people that actually share code online and stuff, like, does everyone just Google all of their code? Like, someone already made the code for all these other games, and if they just shared it, does everyone just go like, oh, I'm just gonna use that, and like tweak it slightly? Or they just blatantly use the same thing? Like, isn't that what would happen? I'm never sure. Because then it makes it sound like, in theory, a lot of this stuff isn't as hard as you'd think to do. It's just a lot of people have to be able to draw, among other things. They need to have some artistic ability to make the textures and junk themselves, to make their thing distinct instead of just being a free asset game. Though if the free asset game then has their own code in it, or if you know how to art well and you just used all free coding that you found online, I guess it's one or the other for some people, or it's a mix of both, or it's you know how to make music and all this other stuff. I guess there's layers there, like an onion. Layers like an onion. But yeah, these tutorials have been fun so far. I hope I get my first badge. I don't even know where to look at these badges. What's the point of earning them if I can't even look at them and go like, heh, look, I got it. I did the ball rolling tutorial. I did it. I did it. And like, obviously all this stuff is really rough brushes, because if you don't know all the you have to know dimensions, you have to know the measuring stuff for it. There's a lot of things you'd have to know. Must be very annoying. I don't know if I would go about doing a 3D game myself. But maybe I'll make a crappy 3D walking simulator. That, it would be funny to my friends or something, so I could show them. And just have some test project that would give me an idea of what I'm doing, you know? Give me an idea what I can do. I just want to be able to see if I can make something, like, that has lip flaps in it, for example. Or something like that. Because I think that would be interesting to fiddle with. Or try and do, like, PS1 cheesy style, just so I don't have to do mouth flaps. Or go like, I can totally draw. See? I made this PS1 crust. Looks terrible. Okay, I can do a better one than that. Now, Unity. Does it say to name it anything? Share your project. Once you've done that, then use the form to submit your required. Please upload your Essentials 3D project gallery to share with others who are starting out just like you. Or Polling all creators. Show us your latest game. Not now. You can continue to change your game in Unity with your maze. Okay. Mod your own game. Okay. Add any additional information about your submission here, including what kind of feedback you'd like to get from your peers. Let's see. Oh, I don't have more. They don't let me add more. Why would I be a robot if I was doing all of that? Wouldn't that be kind of an elaborate thing for a robot to do? Do all of the Unity tutorial? Continue. I guess other people have can show that they've done that too. In this tutorial, you'll identify the role of code in creating experiences in Unity. Now this is the big boy gamer moment. Maybe. Not sure. Create a script component. Interesting. In previous tutorials, you added components to game objects to change their properties and behaviors, in addition to using the components provided. In the Unity editor, you can customize the properties and behaviors of game objects by writing custom scripts in C# language. In this tutorial, you will create a simple Hello World component and add it to the game object. You'll see how you can use scripts to manipulate what appears in the inspector window for any game object. Along the way, you will learn about tools and windows used for programming in Unity. To view transcripts of videos, select Show Transcript while playing each video. You can download a set PDF files, links, material section. Okay. Integrated development environments, IDEs, such as Visual Studios and Writer, allow programmers to write and debug code as efficiently as possible. Support programming in a wide range of languages. G#, Java, JavaScript, Python. Unity development is typically done in C#, pronounced C#. using Visual Studio. Watch the video below to hear how IDEs are used by some of our established creators. I don't know if I can. It's typically possible to write code in a simple text document, but IDE provide developers with a suite of tools to make programming easier. For example, most IDEs include error detection to highlight when something is coded incorrectly, a debugger to help locate the source of the error, syntax highlighting to make error code. You should instantly fill out lines of code. Unity comes packaged with Visual Studio and integrates with Visual Studio to make coding debugging easier than it would completely separate. Okay, so do I already have it then? Visual Studio is typically installed as a module during the initial Unity install. Follow these steps to set your IDE to Visual Studio. Yeah, I get it. Open previous existing Unity project, create a new one via the hub, change the IDE will apply to all other projects. Okay. Edit preferences. In the preferences window, navigation panel, select external tools. Find external script editor settings. By default, this is opened by file extension. If you download and install Visual Studio Community alongside your editor edition, use the drop-down and select it now. Did I? I guess I didn't. Necessary, install the visual module using the Unity Hub. Oh, right. Microsoft Visual Studio. It says that it's installed. Then why can't I see it here? Oh wait. I was under the wrong thing, that's why. Though it looks like I might need to update my thing. So that's all fine. We're good there. SEP inductional. Intelligent code compilation. One of the tools that most IDEs provide is intelligent code compilation. In Visual Studio, this feature is called IntelliSense. This means that your IDE will make suggestions to address typos and common mistakes. You can think of this like autocorrect for code. I remember using this for the stuff that I was doing in Tabletop Simulator when I was trying to make my own D&D character sheet. Maybe this will help me make that better, because I tried to use it before and I thought I was doing okay, but I definitely needed some more work. To check that this is set up for your IDE, type some code and see if your IDE makes compilation suggestions. For the details, okay. It sounds like we're fine. Okay, I guess I did that. Create a new script. Let's create your first script. Open the 3D project you created. For a challenge for a novel, you'll have an opportunity to customize this project further with scripting. Okay, well I already have it up, so guess we did that. if we could edit this more. If we could edit to the point where I can move the ball, that would be cool, but not sure about that. Looks like we'll add audio, maybe. But let's see where this goes. Create an new empty game object in the scene by right-clicking in the hierarchy and select create empty. Yeah, I know that part. Change the name of the game object to script object. Pretty straightforward. Okay, while your new game object is still selected, select Add Component in the inspector window. Select New Script option. I don't see a script option. Wait. It said add component. I'm dumb. Aren't I zooming out? Oh, I guess I was. It's just wicked far away for some reason. Why are you so dang far away? Add component. New script. This typical first lesson in scripting in a new environment is the Hello World exercise, which is what we will do with this new script. Name the new script Hello World and select Create and Add button. Okay. The script is now added to the empty game object as a component, and it also appears in your project's asset folder. Double-click the new script and open it in Visual Studio. (2019) Visual Studio. I wonder if this will auto update now. A little old. Unless this is like newest version. That's all we had to do for that though, so I can move this part along. Move it along, sweetie. Sweetum. Sweetie sweetum. Real-time 2D, real-time industry. A lot of real-time things. Mission, learn Unity. Mission, explore Unity. This is just exploring Unity still. Every time you create a new script, Unity gets you started with a default script that contains the basic lines of code you will need. In this tutorial, we'll give you a tour of default script, write some code to use the functions provided, and link you to some resources where you can learn more. The default script. When you create a new script, you also create a new public class that derives from the built-in class called MonoBehavior. When you named the component, the same name was applied to this class in the file name of your script. It is important that these match. In the code, you will see a public class already set up. It is called Hello World, the same as the name of the script. These names should always be the same If you change the name of the script, you must also change the name of this class. The script also contains two functions, start and update. The start function runs once at the beginning of the game. The update function runs at every frame of the game. More about frames later. Oh, great. Let's see. Devin chat. This is my Microsoft account? I guess it is. My M key would ever work. Hang on one sec. That's fine. Uno momento, por favor. Getting the Visual Studio thing set up because it makes you sign in. Or at least it asks you to. Start with a familiar environment, development settings. I guess this. Choose a color theme. We'll go with dark. I'm definitely familiar with C#. I know all about it. Definitely have used it before. I have no idea what it is. I know I tried to look about how to learn C++ or whatever. But then I didn't understand any of it. No clue what I was doing. Can I like update it now? I just update the thing right now if I can. Okay, well. I just wanted to grab... What we got now? Oh, it is updating. Everything's got to update. Okay, well I'm gonna update this really quick. Or very slowly. Save your work before continuing to close the following MS build. I don't know what that means, so I'll just save everything. I think it meant it was closing what I have up already, is why they were warning. Luckily the update isn't that long, but I had 16.10.2 and it's at 16.11.10. So updates. So pretty much when you make the script, don't change the title. Is what I've gotten so far. We make scripts, don't change the title. I've definitely looked at scripts before for different things. I don't know which things I've looked at. I've made scripts in my old computer class for, like, opening and closing a CD drive or something like that. But I have not done that much else. This is taking a while. I can turn this back on now. Well, that's not telling me to do anything yet. This is what's telling me to do stuff. Add the following code to the start function between the two brackets. Following code. Debug log hello world. We'll wait for a second to get that. I don't know if I should try and finish all of these tonight, because apparently it would take 10 hours, so probably should not go much longer on this. Sorry, 8. Don't want to go forever. Should probably stop soon. I think I'll try and get through this script stuff and before I go on to the next parts. Or maybe I'll finish this this essential of programming thing and stop at the essentials of real-time audio. That could be a better thing to do. And this change a game to object with script is a lot longer. Add a property with a variable, edit the update function, edit the start function, the default script. Yawn. Food. And this takes a while. Everything has to update when I wanna do this. One thing needs the update, then the other thing needs the update, and the other one needs the update. Kirby, the Forgotten Land. XCOM in general is on sale for 95% off. That's pretty good. Fortunately, I own like every XCOM thing nowadays. It's going along. It's at 65%. It's getting there. Letting on. Ugh. I mean, well, I'm not doing anything. Clicking DeviantArt on this is probably a bad idea. Ignore everything there. 17. That's not terrible. Get any comments? I'm almost at 2,000. Well, no, I'm at 2,400. Yeah, that's not terrible. That's okay. No comments. I never get any comments. Now it's at 70%. It only went up 5%. Ah, why must it take forever? Why does Tabletop Simulator have to use its own code? I mean, I guess I don't really need the Tabletop Simulator things anymore anyway.